In the last video, we reviewed a little bit about Booleans, true and false values, and I promised we would learn more about them, and then we didn't yet because we focused on this particular problem of having the robot swap the pattern of lights and darks on the left side with the pattern of lights and darks on the right side. And when we wrote that program, the heart of the program was this piece here, swap row, that just dealt with one row at a time, swapping two colors. And here's the big mess we made of that. We had if-elses within if-elses, and I think you'll agree that in the end, when we look over this program, it is extremely hard to follow what is happening. Although, luckily, we made enough comments as we went, and we were careful in our thinking enough as we went that we didn't make any mistakes. It actually worked first try, which was very exciting. Very exciting. Doesn't happen very often when you're programming, but with your help looking over my shoulder, I didn't make any mistakes, which is wonderful. Anyway, I'm feeling like this is kind of ugly because this is not really how I think about this problem. So I would like to try writing this method again, but this time I'm going to write it in a way that makes more sense to me. More corresponds to more of how I think about the problem. So I wasn't really using top-down design. I was thinking in terms of, I had some clever ideas like sliding left and sliding right. Slide left, slid the robot over without changing its direction. Slide right, slid the robot over to the right without changing its direction. And those were useful operations, high-level ideas. But look at that, I just deleted all my code. One of the things you learn very quickly when you write programs is how to not get too attached to your program, how to just give it up and throw it all out and start over because you have a better idea how to solve it or what you've written isn't working for you. Now actually that did work, but we're going to be smarter. Here's how. I'm going to think in English. So how would I solve this problem in English? Well, if that lit up because it's a keyword in Java, but I'm not going to let that faze me. If the left and right are different colors, then swap them. Wouldn't that be nice if I could write a program that looked exactly like that? So we're going to take a look at how to write that program today. So let's look at that. And to do that, what I really want to be able to do is say if and have my own operation that tests if the left and right are different colors, so that I can test not only is the robot on dark or not on dark, or front is clear or not front is clear, but I can test things that I want to test, like whether the left and right are different colors. So we're going to write that in just a moment. So let's learn a little bit about writing our own conditions, like on dark and front is clear. So how do we write our own conditions? Well, each of these conditions is a method call. When we say robot.onDark, we're asking some method in the robot file called onDark. We're asking it a question, and we get back a Boolean answer. So when we want to define, and that's actually a method, right? This is a method call onDark. It's in the robot file. So we can define our own Boolean methods. And they look just like the methods we've been defining so far, except because they return an answer, we write that the return type is Boolean. So that tells you that when we define a method, let's see, here, let's do that like this. When we define a method, we're really indicating, let's see, we're going to make a lot of pretty colors here. Oop. Some braces. So it looks like I have the outline of a method. Okay, so what I write over here is my return type. And my return type, the only return type we've seen so far is void, and void, let's define the word void. Void means doesn't return a value. My method doesn't return a value if it's void. I don't know why Java and the C programming language picked the word void to mean doesn't return a value. It's kind of a confusing and unnecessarily scary word. But all it means is doesn't return a value, so don't get too hung up on that word. So now we understand one of these magic words we write every time we define a method. Public static, we write the return type, and then we write the method name. You knew we had the method name. And we write a bunch of statements, and that part you knew too. And remember, statements are lines of code that I execute for their side effect, like the fact that they change where the robot is or something like that. But now we have a return type, and the return type could be void, but it can also be Boolean, which means a true or false. So we're going to write right now. In fact, we'll write a Boolean method, public static Boolean, and that means it returns a true or false. And the particular thing I want to write is, let's see, we have front is clear. Let's write front is blocked. Maybe sometimes we wish that we could detect if the front was blocked. So how can we detect if the front is blocked? Here's what we do. We say, if the front is clear, then, if the front is clear, what should I do? Well, if the front is clear, then the front is not blocked. So that means if front is clear is true, we want the answer to be false. So how do we signal that the answer is false? We use a new Java statement. So here's our third kind of Java statement. We have method calls, such as robot.move. We have if statements, like this one here. And our third kind of statement is the return statement. And in particular, the value I want to return is, see, if the front is clear, then it's not blocked, so the answer is false. And if the front is, you know what I'm thinking we should do? Let's write this in Dr. Java so we can actually see it run. Let's do that. Public static boolean. I'm just retyping what we had a moment ago. That was called front is blocked. And front is blocked had one test. It tested if the front is clear. And I'm writing out the entire if, like I always do, and then filling in the blanks. If the front is clear, then we're going to return false because it's not blocked if it's clear. And if the front is not clear, then return true because the front is blocked. So I'm hitting compile. 27 errors. Uh-oh. What did I do? I missed a paren somewhere. Oh, right, because I wrote this little note to myself, so I'm going to comment that out so that my program compiles. So we'll see, we went from 27 errors because of writing in English in the middle to 0. So don't get too hung up on the number of errors. We had one mistake and it gave 27 errors. How about that? Okay, so let's load our little robot world. I think it was called swap1.txt. And here it is. And let's test if the front is clear. And I get the answer true. This is one of the nice things I can do in Dr. Java is I can evaluate a statement and see its true or false result. Or, sorry, evaluate an expression. Okay, so front is clear. So let's try, what did we just write? Front is blocked. And oh no, it says it's never heard of front is blocked. But that's because it's looking for a method called front is blocked in robot. And I didn't write it in robot, I wrote it in the swap file. So again, I need to make sure I'm calling my method with the right file name. So I still need file name dot method name. So is the front blocked? No, it's not. The front is clear. Let's turn around so we can try it in the other direction. Is the front blocked now? Yes, it is blocked because, although you probably can't see this, I'm at the edge of the screen, so my robot is not allowed to move that in that direction. So that's how I define my own Boolean method. And you may not be too impressed with front is blocked because we could have just said not front is clear. In fact, I want to show you, actually let's recap a little bit before I show you something new. So here's what I want to show you. We now have three kinds of statements. We have a method call. We have, and that's something like we'll just write out the examples in a moment. Method call, an if, and now we have return. So method call, that's something like robot.move. If, well, you've seen what an if looks like. Return is, oh, fine, for completeness, where there's a whole bunch of stuff in here. There's a Boolean condition, there's statements here, there's statements here. And return is something like this, return true. But actually, that's not the only form return can take. That's interesting how slowly that slides up. In general, when I write return, let's write it like this, I fill in what the return value, what the return expression is. And it doesn't just have to be a true or a false, it could be something a lot fancier, like robot.onDark or something like this. So in general, this is, switching colors, this is a Boolean expression. And that means we've now seen several Boolean expressions. In fact, I'll add this to the top of our file over here. Here were a bunch of Boolean expressions. robot on dark, front is clear, and we learned how to define our own Boolean expression just now, right? We made front is blocked, right? So let's add that to the list. We've got swap dot front is blocked, and of course it doesn't fit on my screen. And if we can do that, we could probably do not swap front is blocked. But you may have noticed true and false must be Boolean expressions because I can write them in this return. That means I could also write those in an if, right? We could say if true, then I'm writing this all in one line so we can use Dr. Java in this fashion. If true, then move. Otherwise, we'll just do nothing. So let's see, is the robot going to move? Actually, it's going to crash. Oops. All right, fine. We'll turn left so we can turn around. If true, move. Well, true is true, so the robot will move. If we were to say if false, move, well, false is not true, so the robot won't move. So true and false are Boolean expressions. We can use true and false just like we use robot on dark and just like we use swap.front is blocked. In the next video, we'll see how to write this method in an even perhaps cleaner, shorter, simpler fashion than we just did, and then we'll expand and write some fancier Boolean methods and ultimately work back to solving this swap problem. I'll see you in the next video.